Okay, example 8. So what we're doing is we're integrating here. So between 7 and -1, right? It's in the correct form, so we don't need to do anything with it. So we'll just go straight into our integrating. Tidy it up a wee bit. So we got 49 minus 42 minus 1 plus 6, which is going to be 7 minus 7, which is 0. So you might think, why is it strange that we're getting 0? Now, the reason we're getting 0 is if we actually look at this graph. So if we were to draw it, okay, so 2x minus 6, so 7 is there, and minus 1 is there. So really what we've got, it goes right through at -3. So we've got this area here and this area here. Now if we were to split them up and work out 3 and 7, and then 3 and -1, you would get the same answer, but one is positive and one is negative. So sometimes you end up getting 0 because of that fact. Okay, so what we would actually have to do is we'd have to have a diagram and we'd have to work them out separately, and then we'd be able to get the area that way, because the area obviously isn't 0 or it wouldn't exist. So if we have that situation, what we really need to do is you would have a diagram and you'd work them out individually. So you'd have to do like 1 integral and 2 integral. So you would do this first one, you would integrate your curve. Oops. Between 3 and -1, and then you would do the same between 7 and 3. So you would have a diagram though for my dx's, and then you'd work it out that way. Okay, so that's what we're going to do here in this example 9. So what we've got is determine the area of the regions bound by the curve and their y-axis. Now the first thing is, you can see we don't have any information of where the limits actually are. What we do know though is that it's where it cuts the x-axis. So for your limits, that is when y is 0, because it's where it cuts the x-axis. So let's figure that out. Plus 3 is 0. We're going to factorise it. Bring it down. Okay, so that's my answer. It's obviously 1, 3, and we've got 0. So what we're going to do is we're going to work out 2 individual bits. We're going to do the first one, and we're going to do the second one. Okay, so if we do the first one, we have the integral between 1 and 0 of our curve. Put your dx in because you're making your integral. Right, so let's integrate it. So increase, divide by new power. Oops. Sub it in. Make that a 2. Sub in 0, you're going to get 0. Tidy it up. Just take it up a wee bit. So a third minus 2 plus 3 is obviously 1. A third plus 1 is 1 1/3, or 4/3. Okay, so that is, oops, that's the first one done. Okay, we're going to do the same thing for the second one. The only difference this time is we're actually going to go from 3 to 1. Now I'm going to set it up and then I'm going to jump ahead a wee bit. Because if you think about it, we've already integrated this. So I'm going to kind of jump really to here. So I'm going to have x cubed over 3. I know that gave me 2. And you could jump even further ahead, to be fair, but sometimes it's not best to x. So 3 cubed over 3 minus 2 times 3 squared plus 3 times 3 minus 1 cubed over 3 minus 2 times 1 squared plus 3 times 1 Now remember, we've actually just figured that out. Now you obviously can, work out again, but you think we've just figured out that's 4 over 3. Okay, we've just done all that in the previous step and figured out it was 4 over 3. So let's just figure this bit out. So we're going to have 27 over 3 minus 18 plus 9. And that actually is going to give us 0, okay, because that's 9. 9 minus 18 plus 9 is going to be 0 minus 4 over 3, which is negative 4 over 3. Now remember, that is the value, so the area is 4 over 3. Okay, so then our total area, and we should expect a negative as well, because obviously it's underneath the graph. So we add the two of them together. Units squared. Okay, so don't panic if you get a negative, it's absolutely fine. We make it positive for the area, and then we add the two of them together.